we have what are called generic functions. So I just want to review really fast. Y equals the square root of x. What shape is this function? Swoop. Very good. Swoop. So it looks like this to start. Then we had y equals the cube root of x. What is the cube root function look like? What does the cube root function look like?
No,
the wave. Very good. This was the wave function. It's out of ink. Try another one. Okay. The wave, the breaking wave, we had 3 points, 0, 0, 1, 1, -1, -1, and it was just the breaking wave function. Very much a side-to-side graph. Okay. We also talked about the square function, x squared. What does x squared look like? Parabola. Very good. So we had the 3 points, 0, 0, -1, 1, and 1, 1, and it was the U-shaped parabola. So very smooth U shape. We talked about the cubic function, x cubed. What did x cubed look like? Slide. This was the slide. Again, 3 points on the diagonal, and this was the very tall slide, mostly vertical. So we go up, 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 over a little bit, up, up, up. All right, so it's very tall versus this one, which is side to side, okay? You can think about this as it's growing very quickly. If we take a number and we cube it, 4 cubed is 64. So 4 gets very tall very quickly, okay? So this grows very fast. And then the last function that we talked about was absolute value of x. What did the absolute value function look like? V. Absolute value V was the easiest one to remember. So again, we have those three points in a V, -1, 1, 0, 0, and 1, 1, and it is just that V shape. So these were the parent graphs that we were talking about over the last 2 days. And the H and K shift the functions left and right. And the H shifts left and right, and the K shifts up or down. And we are going to do the same thing today, except today our functions aren't equations that we can type into our calculator. So if there's something I'm going to test you on, this is it. Generic functions are that. They are just generic, made-up graphs. I'm not going to give you equations, and instead we're giving you notation, just notation. But they're going to shift the same way that we've been doing. So I'm going to give you a minute to create a good sort of graph here. So example 1, we're going to shift the function according to the function notation. This is function notation. We're going to also describe the domain and range. So I'm going to give you a minute to copy these down. I will pause my video. And so this is f of x, f being some generic function that we made up, all right, essentially. So this is what I would call the original generic graph, okay? This is what we want to do to the graph. You can see that it's referencing our function f, but it's got changes to it. What changes do you see? +3, +2, very good. And so just like the last 2 days, those changes to our function slide it up, down, left, and right. So what do you think happens to f of x plus 3? What does that x plus 3 do to this graph? Left 3 units. That's exactly right. That 3 is inside the parentheses, inside with x, so it's moving it in the x direction. All right. What does the +2 do? Up 2. Again, it's on the outside of the function, and outside is going to affect us in the y direction, up and down. So all I have to do is take these points, just like we've been doing, and slide them left 3 and up 2. So I'm just going to count left 1, 2, 3, up 2, and plot a nice big point. I do have to do that for all of them. 1, 2, 3, up 2. 1, 2, 3, up 2. And 1, 2, 3, up 2. And this is my shifted function. And we're going to label this. This is y equals f of x plus 3 and then plus 2. So that's telling us that we took our f function and we shifted it left 3 and up 2. And that's it. Let's talk about the domain and range of this, which is purple. Domain refers to what? Left. It's the x-axis. So the x-axis moves left and right. Okay. So we want to know how far left and how far right does this graph go? -5. There's our furthest left x value. How far to the right does it go? 0. Yeah, right there. There's our furthest right x value, which is 0. And because those are defined points, big giant starting point, big giant ending point, we're going to use brackets on both of those. Let's talk about the range. The range refers to the y-axis. So we want to know how low and how high. So looking at our y-axis, what's our lowest y value on our purple graph? 1. Right here, there's our lowest y value at 1. And then how high does it go? 4. There's our highest y value right there. So our low is 1, our high is 4, and they're both defined points, so we're going to give them brackets. Okay. Today, you're going to be graphing multiple graphs on one. So that's why I suggest using colors. So you can color code your functions, okay? Otherwise, you just put numbers next to them. All right, let's look at this one. You can see this notation is referencing our g function. So we want to go to the g function, which is right here. So this represents our original graph, O-R-I-G-I-N-A, our original graph. And again, we're going to make some transformations on it. So what do you think x plus 4 is going to do to this original g graph? I said plus 4, didn't I? I meant to say x minus 4. Right 4. Again, everything with x is always opposite. And then the minus 2 says down 2. And again, it's really just because this 4 is inside with the x, we move in the x direction. Anything on the outside is going to move in the y direction. Okay, so down 2. So let's go right 4 and down 2. So I'm just going to take my original graph and slide it. 1, 2, 3, 4. Down 2. 1, 2, 3, 4. Down 2. 1, 2, 3, 4. Down 2. And 1, 2, 3, 4. Down 2. Nothing else about the graph changes, so it should maintain the same size and same shape. It'll be different next week. G of x minus 4 minus 2 is this shifted graph. So we're going to label it so it's clear what it is. And then on your homework, I think you can just put the problem number if you want next to that graph. Let's talk about the domain and range of the purple graph. What's the domain? 1, 5. 1 on the x-axis, 5 on the x-axis. The furthest left point. So brackets around both of those. And range. Excuse me. -4 is the lowest value in the y direction. And what's the highest value? 1 in the y direction. And brackets on both of those. Okay. Very good. Do you have any questions for me? That's pretty easy, right? Today? Okay. So again, you are going to have multiple graphs today on one axis.